In some applications, it's useful to have a geometric definition of a parabola. And it's the set of points the same distance from a fixed point, which we call the focus, as from a fixed line, which we call the directrix. So let's go ahead and draw a point and a line. Well, there's one point that would be the same distance that we could see right off the bat, and that would be halfway between here. And this point is called the vertex. Also, let's take the distance from the focus to the line, go out and form a square, or this way too. Those both satisfy the definition. It happens that if you take all the points that are the same distance, this distance here, we call it A. It's also A down here. And this total distance is 2A, and that's how we found these 2 points. These 2 points are useful because they help us graph the parabola, and the line segment that's formed by connecting those 2 points is called the latus rectum. Notice that the parabola is symmetric with respect to this line here. This is called the axis of symmetry. From the geometric definition, you can derive the equations for the parabola. It's kind of fun to do if you ever get bored. If our parabola opens up, we'll have it in the form x squared equals 4ay, where a is positive. If it's a minus, it'll open down. And for a sideways parabola, we have y squared equals plus or minus 4ay. It'll open right if it's positive and left if it's negative. Let's find the vertex, focus, directrix, and graph of x squared equals negative 6y. First of all, since we have an x squared and a y, it's going to open up or down. And that negative tells us that it's going to open down. We also have that our vertex is at the origin. We need to find a. This is of the form x squared equals negative 4ay. So the 4a and the 6 match up. Okay, on our graph, have 0, 0. There's our vertex. Our a is 3/2, so that means our focus and our directrix will be 3/2 away from the vertex. We're opening down, so this point is going to be our focus, and the directrix will be this line. Now let's draw the points that form the latus rectum, and they're found by making a box. We go 2a to the right and left, so we're going to go 3/2 times 2, which is 3, to the right and to the left of the focus. And you can double check this distance here is the same as this distance here from the definition of parabola. So we can go ahead and draw it. There it is. A parabola has its focus at 3, 0 and directrix at x equals negative 3. We'd like to find the equation and the points that define the latus rectum and the graph of the parabola. Let's graph what we know. There's our focus, there's our directrix. The vertex is going to be halfway between the focus and the directrix. Parabola will open toward its focus. So this one is opening to the right. So our equation will be y squared equals 4ax. And we need to find out what a is. Well, a is the distance between the vertex and the focus, or the vertex and the directrix, so it's 3. That means our equation is y squared equals 12x. For the points that define the latus rectum, we're going to take 2a, which is 6, form a box, 6 up, and it's 6 from the directrix, and here we'll go down 6. Now we can draw our parabola. So our points that define the latus rectum are 3, 6, and 3, negative 6.